So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering and Institute of Aeronautical Engineering. So today we are going to learn about the topic importance of geology for civil engineering. So if you remember in the previous lecture we have discussed about engineering geology syllabus, what is its importance and why we have to study as a civil engineer, why it is important in the civil engineering construction industry, and the various syllabus related to the engineering geology we have discussed. So today we will be discussing about the importance of geology for the civil engineering. So how it is important in the engineering field, in the civil engineering field that we'll be learning. So let us start with this lecture. So in this, let us understand about the introduction part, as we have discussed before about the introduction related to the geology. Now it is related to how much important it is in the engineering geology. So introduction, if we see, geology is the study of earth. So basically if you talk about geology, it's a study of earth. So study of earth means we will be understanding the earth surface features, the underground features, above the surface, beneath the surface. So what is the structure, what are the different kinds of materials are formed by the earth materials, and their process and history. About their history we'll be learning, and it includes the understanding rocks, minerals, tectonic movements. So whatever rock formation will be there, what is the process of the rock formation, what is the process of the mineral formation, and what do you call about the tectonic movements. We will understand what kind of tectonic movements are going on. Like tectonic movements related to the plate, we'll understand that what is tectonic movements, and natural events like earthquakes and volcanic eruptions. So this all we'll be understanding first of all before we look into that what is the importance as a civil engineering point of view. So first we should understand about the introduction part. What is geology exactly it is? So we will be understanding about the rocks, minerals, tectonic movements, earthquakes and the volcanic eruptions. So geologists also study how earth has changed over time and how it continues to evolve. So geology has, it's a study of earth surface, it's a study of the earth, how it is changing day by day over time and how it continues to evolve continuously, the earth, how it is changing, what is the process behind it. So that all we'll be understanding as an introduction. So geology is a scientific study of earth. It's a scientific study of earth, its structure, substances, history and the process that have shaped it over time. So it's a scientific study of the earth and what is the structure of the earth, what are the substances in the history, and what are the processes that have shaped in the over time. And it encompasses a wide range of topics. It encompasses a wide range of topics, from the materials that make up the earth to forces that drive natural phenomena like earthquakes, volcanic eruptions, mountains and their formation. So it's a wide range of topic we discuss, from the material that make up the earth's surface to force and to drive the natural phenomena like earthquakes. Earthquake is a natural phenomena, volcanic eruption is a natural phenomenon, and mountain formation is also a natural phenomenon. So to understand this, we have to learn about the geology. So geologists seek to understand the earth's past. They seek to understand the earth's past, their present and the future, focusing on the interactions between Earth's internal processes and its external environment. So geologists will seek to understand what are the different features happened before the Earth past, the present, the future, and the interactions between the Earth internal as well as the external environment. So earth material, when we talk about the earth, so earth has a different materials, how it is processed. So we have about the rocks and minerals. So when you talk about rocks and minerals in geology study the composition, classification and properties of the rocks and minerals. So when we study of rock and minerals, geology will study, in geology we will study the composition, how it is composed, and what are the different classifications and what are the different properties of rocks and minerals. So rocks are classified into three main types. So if you talk about rocks, they are classified into three main types. So what are the three main types here? Igneous rock, sedimentary, and metamorphic. So it is classified as a igneous rock, it is classified as a sedimentary rock, and it is classified as a metamorphic rock. So when you talk about igneous rocks, so these are the rocks which is formed by cool magma. Cool magma or lava means, so whenever a volcanic eruption happens, the melted lava and the magma will come out as a molten material which comes out on the ground, and when it cools down it forms as a rock. So that kind of rocks we call it as igneous rocks. So we have one more type of rocks called as sedimentary. So these type of rocks, they are the rocks which are accumulated from the sediments, and they are composed of sediments, all the sediments which are derived together, and it is deposited at one place, and this kind of rocks we call it sedimentary rocks. So formed from accumulation of the sediments. So these are formed from the accumulation of sediments. Next we call it as metamorphic. So what is metamorphic rock? So metamorphic rock formed when existing rocks undergo heat and pressure. So whatever rocks are formed in the environment, like if igneous rock is formed, when a sedimentary rock is formed, so metamorphism happens when the present rock goes with a heat and undergo with a heat and pressure environment, and that will form as a metamorphic rock. Now minerals, naturally occurring substances with a specific chemical structure such as quartz, feldspar and calcite. So this all we will be getting from the earth material. Now when talking about the plate tectonics and the earth structure. Plate tectonics and earth structure. So what is plate tectonics? So the earth outer layer, we call it as lithosphere. The outer layer of the earth, we call it as lithosphere. So which is divided into tectonic plates that float on the semi-fluid atmospheres beneath. So it comes in a semi-fluid state, and the tectonic plates will be floating on this semi-fluid, which we call it as atmosphere beneath. So the movement of these plates is responsible for much of Earth's geological activity. So whatever movement happens of these plates, it is responsible for the Earth's geological activity, including the earthquakes, volcanic eruptions, and formation of the mountain ranges. Now continental drift. So what is continental drift? So continental drift is related directly to the when you talk about the plate tectonics. Okay, so continental drift is a kind of, it's a theory. Actually, it's a theory given by the person who has just explained that Wegener, the person name is Wegener, and the theory says that continents were once connected and have since drifted apart, explaining the features like matching the coastline, similar fossils, distributions across the continents. So continental drift theory is a theory once it is connected, since it is drifted apart, explaining that. So what it says is, before there was a single continent. Now we have 7 continents, 7 major continents. So before it was a single continent, we call it as Pangaea, which was having a plate boundary. Suppose this is the continent, it was having a plate boundaries like this. So these are plate boundaries. So what happens, these plates will be continuously moving. So at the speed of 10 centimeter per year. Okay, at the speed of 10 centimeter per year. So these plates will be moving on the atmosphere surface on a semi-fluid region, and explaining that which will be moving continuously. That theory gives us the proof that it was combined before and later it has moved apart, and these feature matching coastlines and similar fossil distribution across the continent. So the coast of these kind of plates will be having same type of features, same type of species present in that area. So this proves that, so before there was a single continent, later it has moved into different separate continents. Now this is the what we say is layers of earth surface. So the earth surface, when you talk about the layers, so earth is divided into different layers. One we call it as inner core, the other one we call is outer core, and mantle, atmosphere. So this is the atmosphere where the plates will be floating. Okay, so core is the inner core, has a 6,378 kilometer inside it is, which we call it as core, and 5,100 kilometer we call it as outer core. Mantle will be 2,900 kilometers, and crust is 0 to 100 kilometers above the mantle. So where in the crust, this atmosphere we call it, where the plates are continuously moving at the speed of 10 centimeter per year. So next we when you talk about this geological time, so when you study geology, so this we have to understand what is geological time. So geologists use the concept of geological time to describe the Earth's 4.6 billion years of history. So in this, geologist will tell you about the time scale. So in this time, how much old the Earth was 4.6 billion years ago, or what was the era, which time period, which kind of species were present. That all information, when we study about the geological time scale, it will give us. So this is broken down into eras, periods, or epochs. So this the geological time scale, we call it as geological time scale. Time scale is divided into eras, periods, and epochs. Okay, so the geological time scale helps scientists organize the Earth's history, understand the events that shaped it. Next, when you talk about erosion, sedimentation, and weathering. So this all we have to understand when you study the geology. So geologists study how rocks break down, we call it as weathering, and how they are transported, we call it as erosion, and how they accumulate in the locations, we call it as sedimentation. So these processes shape the landscapes and create geological features like valley, mountains, and deserts. So we study about erosion. Means erosion is a process from where the top layer of the soil is washed away by wind or water, and sedimentation is the process where all the sediments through the erosion, when the sediments are carried out and they are deposited at one place. So we call it as sedimentation. Then weathering is the breaking of the rock due to the weather condition, due to the climatic conditions. So this process shape landscape, create geological features like valleys, mountains, and deserts. Natural disasters. So when you talk about natural disasters, geology helps to understand and predict the natural disasters such as earthquakes, volcanoes, landslides. So it will help us to understand the basic information or the basic problem. What is the cause of the disaster? What is the type of the disaster? How the disaster is occurred, and kind of natural disasters like land-based disasters like earthquakes, volcanoes, and landslides. This all we are going to study in this. By studying the Earth's crust and the forces that cause these events, geologists can help us to mitigate the risk. Mitigate the risk means once you understand about the earthquake, once you understand about the volcanic eruptions, when you understand about the landslides, then we are able to, or geologists are able to find out the solutions for it. They are able to mitigate the solutions for it, and they try to improve the safety measures. Next, fossils and planetology. Planetology means the geologists often work closely with paleontologists to study the fossils. They want to just study the fossils and interpret the past environment. So they will just interpret what was the past environment based on the fossils present in that kind of environment. So fossils provide evidence of ancient life forms. They help the scientists to understand how life evolved and how the environment changed over the time. Now let us understand. Now let us know what is the importance of geology from civil engineering point of view. So till now we have seen the introduction. Now let us understand what is the importance from the civil engineering point of view. So when you talk about this, let us see the introduction part. So geology plays a vital role in civil engineering as it provides the essential information about the earth materials, their properties, their behavior under various conditions, and understanding the geology helps the engineers. They can help the engineers to design and to construct structures that are safe, stable, and durable. So they will help the geologist, they will make the geologist, and they will make the engineers to help to understand the design pattern or the construction structure and structures that are safe and stable and durable, and even they help the engineers to mitigate the solutions based on the type of the rock or type of the material whatever present over there. Now, next thing is reasons why geology is important in civil engineering. What is the main reason? First thing is site selection and evaluation. So site selection means that when you talk about civil engineering, it is the civil engineers are the engineers, those who will construct the houses, the transportation, the total infrastructure, where they will be using this kind of geology materials like earth materials, like they use stones, they use minerals, they use aggregates, they use soil. So these all materials, the materials from the earth surface, they use it in the construction. So how much durable it is, how much it is having the capability, how much resistant it is, and how they provide how which kind of projects can be carried out in that particular sites. So geology helps in identifying suitable locations for construction projects such as buildings, dams, tunnels, and bridges. So they will help us in site selection and evaluation. Geology will help us. First of all, they will help us to identify the suitable locations for construction projects like building dams and tunnels. So it provides information about soil, rock, topography, subsurface conditions, and critical site feasibility and studies. Now, foundation design. Knowledge of geological conditions ensures that foundations are placed on a stable and load-bearing strata. So it is placed on the foundations wherever the load-bearing strata is formed, and engineers can assess the risk of settlements. They can just assess the risk of settlements. Liquefaction. So what is liquefaction? Liquefaction is the soil will become loose, so it will act like a liquid. So liquefaction occurs whenever the earthquake kind of condition occurs. So they will understand the risk of the problem of or the vulnerable areas, whichever it is in the risk conditions, and they can avoid construction over there, and so slope instability, reducing the chances of the structural failure. So they have to understand the foundation design. Third thing, if you see here, material selection. So geology aids in identifying the suitable construction materials such as aggregates, sand, rocks, and ensuring the quality and the availability. Understanding the durability, strength of materials help in selecting the most appropriate resources for the specific projects, and assessment and in natural hazards. So geological studies help in identifying the areas which are prone to natural hazards such as earthquakes, landslides, floods, and volcanic activity. So this will help us, the geologists, to assess the areas which can be identified and the areas which are prone to the hazards, and such as earthquakes, landslides, and floods and the volcanic activity. So engineers use this information to design the structure. They can withstand these hazards, ensuring the safety and the resilience. Next is water resource management. So water resource management is also one of the most important part in the construction field in the civil engineering point of view. So water resource management, geological knowledge is crucial in understanding the aquifers, groundwater flow, water table levels, and water supply and the drainage system. So this knowledge is very much important to understand about the aquifers, how much water is present, how much underground water is there, what is the groundwater table, and what is groundwater, what is surface water, what is the groundwater flow. So this all a geologist has to understand, and it helps the designing, which will help them to designing the dams, reservoirs, irrigation system by evaluating the geological and hydrological conditions. Now, tunneling and excavation. So what is tunneling and excavation? So geology provides insight into rock formations, fault zones, joint system, which influence the method and the cost of tunneling. It helps in anticipating challenges such as rock fills, rock falls, water inflow, unstable ground during the excavation. And next thing is soil mechanics and the geotechnical studies. So soil mechanics or geotechnical studies, these kind of studies are totally related to the type of soils. So soil plays a very, very important role in the construction field, because the type of the soil they are using for the construction will help the engineers to design and to make them understand the durability and stability of the structure. So engineers use geology to study soil properties such as permeability and compaction, shear strength, and the bearing capacity. So they have to understand, a civil engineer has to understand when they go for the construction work, what is the capacity of the soil, what is the durability of the soil, what is the type of the soil they are using, and what is the strength of the soil, how much soil they can bear. And this knowledge is essential for designing pavements, retaining walls, and embankments. Next is slope stability and landslide prevention. So, what is slope stability and landslide prevention? So, geology helps in analyzing slopes, designing measures to prevent the landslides, especially in hilly or the mountainous regions. So, how in a slope landslides will happen definitely in the regions where you have mountainous regions. When you have a kind of slope, very steep slope, and whenever the type of the rock and the type of the soil, when it is kind of a rock is soft kind of rock, type of the soil is a soft kind of soil, will definitely go with this landslides. So to prevent the landslides, especially in the hilly and mountainous region, they have to study about the slope stability and the landslide prevention. So techniques such as slope reinforcement and the drainage systems are based on the geological evaluations. Now, understanding the weathering and erosion. So, what is weathering and what is erosion? So, geology informs the engineers about the impact of weathering. So, what is weathering here? So, weathering is the process where a rock will be break down into pieces due to the physical environment or chemical environment or due to the human activities, and erosion on the structure over time. So, proper materials, protective measures can be chosen to counter these effects. Now, energy resource exploration. So, geology is essential for locating the assessing the resources such as coal, oil, natural gas, geothermal energy. So, these resources are often utilized in the civil engineering projects for energy supply and for construction process. So, these are the references you can just go through for understanding about more about the importance of geology in the civil engineering. So these point references you can go through and just find out the more content about this. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.